All right, gentlemen and lady. Uh, so today we're going to be expanding on what we did last time, which was we made this thing. I think we also covered the discriminant in this. That's just this value that comes off of here. Um, that just basically it's a Boolean value that essentially determines whether or not the plane exists in this direction or not, right? So um, without it, you get a little bit of weirdness, but whatever. Anyways, we're going to be expanding on this concept and more direct applications. So now that we have a plane intersection function, we can create intersection functions with stuff like cubes, which is what we'll be doing in this episode. And then later on, we'll get to more indirect applications of this, like, for instance, shadows and volumetrics and all that fun stuff. Anyways, without further ado, let's get started. So the first thing we need to do is we need to add another output here, and this is going to be the t value that we had last time that we're plugging into that. So that's going to be the output of this divide node. So I'm going to call this t. Alright, and that's basically going to determine how far away this plane is from us. So as you can see, like as we zoom out, it gets farther away. And basically, we cannot directly implement this into creating any more complicated solids. We have to take the minimum of t values and then sort of re-integrate these two things. But we can use this math right here. Basically, that's because if we just add these together, you're going to get if it's a non-planar solid, you're going to get two intersection points, and how do you determine which one is the one that's closest to you, right? That's sort of an issue. So we got to use distances, and we got to compute those distances. So we're going to start with the most basic function, and then we're going to build this into a little bit more coherent of a function. So basically, what we're going to do is we're going to make one side, then another. We're going to duplicate those two, and then duplicate them again to cover all 6 sides of a face. And then we're going to show how to combine, or how all 6 faces of a cube. Alright, so we're just going to assume we're going to use a cube with basically sides that are or side length of 2. So we can just say this plane is at what am I doing? Yeah, so this one's at the top, and it's going to be set, the plane origin is going to be at 0, 0, 1, right? It just makes the math a little bit easier. Let's multiply this by the discriminant, just so we can see what we're looking at. Scale. Oh, not that. What am I doing? Okay. What's going on here? Oh, haha, that was a bit stupid. My bad. My bad, fellas. So there we go. That's better. I accidentally flipped my viewport around. Yeah, there's going to be a couple of shit like that happens. So as I said, we can't directly use this vector output but we can use this discriminant at the t. So what we need to do is we need to create a separate xyz, and then we need to use, like, we need to define the bounds on this plane. So we're going to use the x and y for this one because this was facing up in the z. So we're going to use just regular math, greater than and less than. So greater than -1 and less than 1, and then we can do an AND operation, which is actually just a multiply. What's going on? Greater than, less than. Okay. Yep. And then we do the same thing with y. I'm actually going to use these for the x's. Oh wait, I did something. These are going to be the x's. These will be the y's, just to keep it a little bit neater. So there we go. Those are two sets. Then we're going to do another AND operation, which is a multiply. I'm going to use those two interchangeably. Boolean AND is multiply. So there we go. Lovely. And I'm going to see, yeah, we're still going to have to use, you still have to multiply it by the discriminant, just so that it doesn't do that shit, right? Yeah, there's one side, right? So now what we need to do is we need to basically make this into a distance field. So we already have a distance field to a plane. That's the t value, right? That's how far away this is. So if we use a mix RGB, color, mix RGB, actually, you know what, I'm going to keep this into math. So I'm going to create a mix function. So we're going to have a multiply here and then a subtract, and this is going to be 1 minus. I'm going to clamp both of these. So this is a mix RGB thing. Basically, this is just a mix function. So if this is 1, as it is, it's going to execute this. If it's 0, it's going to execute this. So it's 3 nodes to do what 1 node could do, but it also keeps us within scalar operations, which is nice. So if we are on white, we want to execute this t value, right? Oh, we shouldn't be multiplying that, my bad. You need to multiply it, you need to execute that t value, right? But if we are on black, which is this, we need to use this thing. We need to find a distance field that'll work here. So my solution to that is always to use the camera position, and then I'm going to use the length for that. So I need to do vector math, and then I'm going to do length. I'm going to put this right on there. I'm going to try to make this neat as possible. That way it's easier to understand. There we go. That's pretty good. So I'm going to use the length, and then I'm going to add I'm going to add 2 to it. The reason why I'm adding 2 is because we need to think about the max distance that we could ever have in our plane. So if the, or in our cube, so if the plane's centered at the origin, or if the cube's centered at the origin, and the farthest distance it ever gets away from the origin is, it goes to the point 1, 1, 1, so 1 in the x direction, 1 in the y direction, 1 in the z direction. The maximum point that you're going to get away from that is, or the maximum distance that you're ever going to have between a camera and a point on the cube is the distance between the camera and the origin plus the distance between the origin and the furthest point. And that will always be true, just because maths. So technically this would be square root of 3, which we can put in here, because it's going to be the square root of 1 squared plus 2, or 1 squared plus 1 squared plus 1 squared, which is the square root of 3. So this is the max distance that this plane could ever be away from the camera. So that's going to be this, and then we're going to add these up. We need to take away this clamp. Alright. So you see the plane is always less than, the plane is always going to be closer to the camera than the background. That's even true right there. You can see it's sort of blending in. Alright, so that's one plane. Now we need 5 more. And luckily, the others are pretty easy. Oops. So I'm going to neaten this up a little bit. So we want to reuse as many nodes as possible. Like, that's always what you want to do in these things, because you want it to be as computationally efficient as you can possibly make it. So I am going to select everything here that we still need to do. Including this, and not that, but this. Then I'm going to Control Shift D and move that down to a point that's like sufficiently far below it. And then I'm going to just for neatness sake, I'm going to be doing this shit because I can, and because it makes stuff neater. So take that. Yeah, so it's important to be kind of neat in your node setups. So I'm going to connect this up to that. There we go. Yay, and it's neat. So this is going to output us the exact same thing, but we want the plane origin to be below. Alright, so this is going to be the negative, like the bottom of it. Then how we combine these two is we just take the minimum. So I'm going to do a minimum operation between these two. And we will see yeah, we see suddenly I'm gonna multiply this by a smaller number so you can see sort of what I'm talking about. Like, look, now we have two faces that are intersecting properly. Alright, it's pretty cool. Pretty cool. Alright, so now we've got, so that's one set of faces. Now we can just duplicate this for the others. I'm going to duplicate this whole thing, and then we'll reconnect stuff up when we need it. Let's go down here. That looks good. Then I'm going to grab these guys and move them back. GX. and then G. I'm slightly neurotic about this today for some reason. Just bear with me here. Yep. Yay. All right. Looks like we are mostly good. All right. There we go. I'm gonna move this a little bit over. So now we've got the same thing here, but we need to rotate it a little bit. So what we're gonna do is we're gonna push this into the Y direction. So this is gonna be 1, 0, 1, 0, right? And then -1, 0, 1, 0. Alrighty. And then we are going to I'll show you sort of the problems that we're having. So we get stuff that we're supposed to get right here, but we unfortunately run into a problem around over there, which is like we get this wacky shit. And the reason why is because we're still using the X and Y values when we need to be using the X and Z. So we are going to use X and Z here. And there we go, that solves our problem. And we need to do the same thing over there. Basically, you want to use the dimensions along which the plane travels. For rather obvious reasons, right? Like if the whole plane is situated at like Z or Y equals 1, or Y equals -1, if you say Y is greater than 1 or less than 1, it'll spit out weird stuff, right? That doesn't really make much sense. And you could technically include it, but like, why would you? Anyways, there we go. There's our other two sides, and then we're gonna also take the minimum of this with the other stuff, which is, oh look, I actually got it correct. So minimum between this and that. Sweet. Now we just repeat the process for the other sides of the plane, or of the cube. So Control-Shift-D, Y, and there we go. Doesn't really matter, but we should probably link up these so that we don't have to deal with other problems. All right. Now, what we're going to do is we need to change this from Y to X. So 0, 1, 0, 1, 0, -1, 0, 1, and the same process, except this time we're excluding the X. So Y, oh, my bad, Y, and same up here, Y, still, come on, there we go, and then I want to HGX, bring that over a little bit, and then another minimum. see if we can grab that. This is a bit of a long one. Alrighty. Oof. Alright. There we go. That is the distance function for our cube. And you can see it actually is a cube. So now we've got the t value. So what do we need to do with the t value? Well, we need to take, we need to add it back to the initial position. So that will be, yeah, well, so we need to multiply it by the direction and then add it back to the initial position, which is the camera position. So we're multiplying it by this and then adding this back in. So I'm going to bring that up a little bit. So I'll put that right there. And bring that up. And over. And then we're going to use a vector math. I'm going to scale this by that. And then we're going to add back in the initial position. I'm going to put this in the bottom slot, move this over, and we're going to bring this up. This over. I wish Blender's interface with it for this was more streamlined, but you know, you get what you get. And there we go. And let's bring that down. And voila. That's pretty cool. Alright, now we need to update the discriminant function. And basically, how you do that is you can literally just use the length, right? So because the t value, this is the t value, is set to be this value whenever whenever it doesn't intersect with the plane, you can use that fact again to create a discriminant. So I'm going to say, I'm going to take the length of this. Or actually, I'm just going to use a math and a less than this. All right, and then that's going to be the discriminant. Alrighty. So I'm going to move these back a little bit, and then I'm going to plug this into a function. I'm going to Control G. Let's neaten this up a little bit. Ray direction, ray origin. All right. Let's go in there. All right, fun stuff. So this is lovely, but what if we want more than just a cube, right? What if we want to make like a rectangular prism? Or what if we want to change the size and shape of this and all that shit, right? Like what do we do then? So you can probably figure this out by yourself, but I do want to briefly walk through like the process. And by the way, I'm going to call this, damn, it really got shifted over, didn't it? I'm going to call this the RCIF. RCIF. I'm going to save this right now. Anyways, how you do that is you need to, here, I'll just walk through the steps because I think it's necessary. Yeah, necessary and proper. Basically, you need to, the easiest way to deal with stuff like cube origin is to, instead of adding or just add the location for like the bottom left front corner or whatever, just use the locations of two of the vertices. So in this, I'm going to duplicate this. I'm going to call this lower vertex, and then upper vertex. And I'm going to have upper vertex be 1, lower vertex be -1. And I'll just change this to reflect that. So this will essentially be the coordinates of like it'll be the coordinates of this point up here and like this point down there. So how I would go about doing this is I would basically plug in, I'd start by averaging out the position to find the position of the center. So I'm going to use vector math. I'm going to add these two together and then scale by 0.5. And that will be the updated position of the ray origin. So I'm going to add this to that. How should I go about this? I don't want to make this messy all of a sudden. Oh, that's probably how we should do it. So basically, if I change one of these to be like that, I suddenly shift everything over. But I also have to, actually, sorry, I have to subtract these instead. But I also have to add this shit back in. So at the end, I will have to do that. So I'm just going to duplicate this. Why is this all the way down there? Oh, I know why, but it shouldn't be. Then I have to either add or subtract this. We'll see. And let's make this fit in a little bit. So if we change this up, yeah. Yeah. There we go. So I'm going to set that back to 1. Now, what we also need to do is we need to update our plane origins. So we need to do this for for each face, unfortunately. But it's pretty simple. So we're gonna do separate XYZ. So lower vertex, then upper vertex for each of these. So actually, we don't need to do that. So I'm just showing you sort of how I do node trees for like official projects that need to like be very neat, which is why I'm going through all this, even though it seems like I'm wasting a lot of time. But like this is so much more readable than random shit. I should have probably specified that earlier because I'm probably irritating a bunch of you, but like this is necessary and proper. Anyways, let's just do a separate XYZ, and we're going to cover the lower ones first. So we need to implement the like proper placing for all of this shit. What am I trying to do? Okay. All right. So upper vertex. It seems we should start with that. So I'm going to duplicate this. So this is lower vertex. This next one will be upper vertex. Basically, we need to update the plane origins for each of these. Oh, that's a fail. So our plane origin up here would be, instead of like, this is the upper vertex, and this would, we need a Z value from that. So we're going to use the combine XYZ. Oops. Converter combine XYZ. And then that's going in here. So I'm going to put that there, and then another one over here, and there we go. That's going to be our plane origin there. And then we need to add in another plane origin for down here, which will be -1, so that's going to be the lower vertex stuff. I'm also just going to set these guys up so that we can use them later. All right. Actually, these need to go a couple over. And then I'm going to Control-Shift-D. Oops. Shift-D. Y. Alright, and connect these up, and this is just so that we have them. Alright, so we need the bottom one to be the Z value for this, so that's going to be right there. It's going to be the plane origin right there, and GY, there we go. All right, so let's grab these two and move these down as well. So next one will be right here, and that's going to be, let's see, what is this? This is Y upper. So Y upper, that is this. All right, Y upper. All right, we're all good. We'll know we did something wrong if something changes. And then let's go Z upper next, just so that we can maintain the continuity. GY. All right, sorry, X upper. It's kind of hard. These things are mouthfuls. There we go. All right, now we need to do the other lower ones. So these are going down, GY. All right, this is the next one. This will be Y lower. So combine XYZ. Y. There we go. All right, that's lined up. All right, and then next is Y lower, or sorry, X lower. GY. Duplicate this. This is going right there. This is going to be X lower. All right, so we got that shit sorted. Yeah. I think this should all be good. Let's hope. Let's change these to like 0. Sweet. Actually, so my bad. We actually do not need this. Oops. I'm gonna mute this and mute this. All right, now let's try this. Let's set this to 0. All right, sweet. So now let's tackle problems with the limiting the bounds of the faces. So the bounds of the faces are controlled in here, right? So this is X lower, this is Y lower, this is X upper, this is Y upper. So we need to add in some more handles for these. Alrighty. So I'm going to put some stuff there. Actually, we can probably just reuse these. All right, so that is, oops. So let's see. So this is X and Y lower. So let's plug those in. How should I do this? I'll sacrifice a little bit of neatness for brevity's sake. So that's Y lower. So that needs to go. No, I'm not going to do that. You must maintain consistency. All right. Alright, so that's X lower, so that's going to go up here. See? It's already happening. It's lovely, isn't it? Alright. X lower and X upper, which will be well, actually, let's first tackle Y lower. So that's this. Alright. Sweet. We're getting shit done. I'm going to move this up a little bit to match. And I'm going to, here, I'll move this up as well. And over. We could probably do with moving all this shit over one as well. And then containing a bit of shit. Actually, no, that's not necessary. Okay, now we need the uppers. So let's duplicate. Actually, we'll move this back. And we probably don't need that. Just move it up there. Yep. Okay, so the uppers. X. Actually, I'm going to move these down a bit. X. Do I bother? Yes, I bother, because I'm absolutely crazy. Yeah, this is... Nah. I'm not doing that. Yes, I am doing that. Oops. Alright, there we go. Move this up. Oh, wrong way. And over. Alright, so we have X and Y upper. Alright, yeah, so X is the top one. So X less than 1, so this is going to be X upper. Y less than this. Sick. Let's move these down a slight bit. Alright, there we go. Love to see it. And this one's going to go way down because it's neater. Alright, sick. So that is one face out of, unfortunately, 6. Look at this node tree, though. Isn't that fucking fantastic? I love it. Luckily, the rest are going to be a lot easier. So we can basically like duplicate what we did over here. I'm going to just carefully select all of that and Control-Shift-D. And yeah, like literally right there. Okay, so this was connected to here and here and here and here. See? There we go. Alrighty. So that is X and Y. Now for the next one we need X and Z. Alright. So X and Z. Let's get to it then. So that would be right here, 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 here. Alright, so we need to grab these two. I'm going to bring this down. Where should I bring it down to? I'm going to bring it straight up. So we need, that's Z, that's our Z channel. This is our X. Let's move these up a little bit. And these ones will move over. All right, so this is X. Specifically, this is X lower. So I think it's this, right? Yep. Yep. And this is Z lower, which is, yep. Sweet. All right, now we need X and Z upper. So bring that down. I'm gonna grab this up a little bit, and then we need, come on. There we go. All right, so this is, I believe, right here, right? That is X. And then we can literally bring this one down. It's right here. And there we go. Sweet. Alrighty. I'm gonna make a few cuts over here and over here, and we will bring all of these down with, oops. Is that gonna work? Yeah, it'll work. Whatever. Okay. I'm gonna connect these back up. Alrighty. Now we just go as we're told, I think, right? Yeah. Okay. Sweet. All right, that's the 2/3 done. Now we need just these last planes, and we are good. Alrighty. All right, let's see what we got to do. So now we have Y and Z. So we got to bring. Let's see. So this is Y. All right. So y is this, what's this last one? That's x. How's this working? Okay. Let me hope I didn't get these flip-flopped. So that's x, and then z. Okay, we're good. Thank God. All right, so this is z. So we need x and, no, not x and y. We need y and z. All right. So that's where y goes down to. Okay, that's y upper, right? Is that y lower? Or sorry. Wait, what? Oh, yeah. I'm confusing myself. All right, so this is y lower. So I'm going to bring this down a little bit further. And then we need y upper, which will be this. All right, so that's y lower and y upper. And then we need z, which will be right here. I'm going to grab that, pull it down. It's going to be z lower and z upper. All right, so that's y lower, so greater than that. So let me just pull all these over. Shift D, X. All right. It's kind of hard to keep track of all this stuff. Luckily, this is the last one. Okay, so I'm going to bring these over. So these are the lowers. So this would be this is Z, right? No. This is Y. What? I'm confusing myself here, lads. I'm sorry. I think we might have better luck doing that. So that's going into the Y. Let me move this all down. All right, Y, Z, Y, Z. All right. All right. These are the lowers. So Y lower, that's in here, right? Z lower, that's in here. Yep. Y upper, that's Z upper. That's Y upper. That's going right here, right? Yep. GY. G. Okay. And that's going right here. Right, so that's Z upper. Yep. Okay. What to do now? Make this a little bit neater. Alrighty. Sweet. Alright, now we just need to do the same thing we did for the last one, which is duplicate these all down for the other one. So Control Shift D, Y, and stop right there. Sweet. That goes in there. That's in there. That's in there. That's in there. Sweet. Now we have a cube. And let's test out sort of what what we can do. So if we set this, that should get lower. Yep. We set this should get lower in the X direction. So we'll go back a little bit. Sweet. Now there is still a problem we have, and that is this. I think. Yeah. Yep. So it's not really apparent, but you'll start sort of seeing it right there. Like it's going to intersect with the cube a little bit. We just need to essentially push the background back far enough that the cube is entirely in it. So again, we need to find the farthest vertex from the thing. We don't need this anymore. Thank God. Actually, we probably do. We need to find the vertex that's furthest away from the origin and make that as where the background goes. So there's a fun, quick little way to do this, which is essentially you take the absolute value of the big vertex, the upper vertex, and you add it to the absolute value of the lower vertex, which is what we're going to do. So I'm going to bring this up. Actually, I'm just going to move this over. And move this up. And then you take the length of that. So I'm going to vector math absolute of this. And converter vector math length. And then I'm going to add these together. And that essentially just makes sure that everything is going to be within the cube. And then we can essentially just replace this statement with that. Oh, well, at least this add part. So I'm just going to connect this up. And let's see, where should I put this? All right, that seems appropriate enough. Yep, there we go. See? All right, and then our discriminant should be appropriate. Yep. I'm going to call this the discriminant. And then I'm going to use this, which is the t value. That's going to be our new t. Oh. T. Sweet. So, you guys are probably bored as hell by now. Because this has been going on long enough, to say the least. It's been like an hour long. But we made a cube intersection function. I'm going to converter to math. Scale with the discriminant. Lovely. And now we can do fun shit like making it that might be something to look into. It should be fine. Yeah, so it's not perfect. What's going on there? Something's off. Anyways, I'll fix whatever's happening here. Okay, you know what? I'm going to fix this off camera. You guys get the gist of it. I'll put the blend file in the description when I upload this. But yeah, see you guys.